Hey, seventh grade. Good to see you out here again. This is our fourth video in this series this week. And so I hope that you did okay on the three sections yesterday. Notice how related they were, okay? They're all centering around this basic formula for area. But instead of using length times width, you're doing base times height. Because if we change it to base times height, then it works for all the different shapes, okay? So just remember, just real quick in review, that if you have any kind of a rectangle, including a square, that you're going to take one of the bases, okay, times one of the heights. Even though you have two heights, two bases, you're only doing one base times one height, okay? So just keep that in mind, all right? And when you get to a parallelogram, what we traditionally think of as a parallelogram, okay? The bases, even though they're offset, the bases are still the same length. So we still just have to use one base. Now, when you come, remember, and if this was confusing for you, again, think about this. This diagonal line here, that's not going to be truly the height, because the definition of height is a perpendicular line to the base. It's a perpendicular line actually between the two bases. Okay? So you've got base one, and this one up here, because you could flip it over, and that could be the base also. So you got base one and base two. You got two bases, and you actually could draw a perpendicular line anywhere between those two bases, as long as this is truly perpendicular. Okay? A lot of times you'll see it, and when I was doing the things yesterday, I was drawing the height over here. Okay? This whole thing is the base, but then this perpendicular line is the height. Okay? So, even though there's a height here, there's a height here, there's a height here, you're just taking one base times one height. All right? And then, remember, what we have as we traditionally call a trapezoid. Okay? It really doesn't matter the shape of the trapezoid, just the fact that the two bases have to be parallel. Now, what you'll notice about this is this base is not the same length as this base. And so you can't just take this base because it's not representative of both bases. So what we actually have to do here is we have to get the average of the two bases. Okay? So think about how you do an average. You add the number of things together that you're averaging, and then you divide that by the number of things you're averaging. So this right here, altogether, actually winds up being the base. Okay? And then the height, again, has to be this perpendicular line to the base. That's your height. So it's still base times height. It's just that it's average base times the height. Okay? And it doesn't matter, like they show one in the book, or it's like this, and then there's another line over here. Okay? So it's still, okay, it's still the average of this base and this base, but there's a couple of different ways you could think about the height. You could do the height like this, like we've been doing, or you could take and put an imaginary like that and take the height from there. So it really doesn't matter. You can still do it like this, okay? And then, as we were talking about yesterday, a triangle. So a triangle is just half of a rectangle. So instead of taking base times the height, you're doing 1/2 the base times the height. And that would be the area of the triangle. Now the examples look like it's all going to be right triangles. It doesn't, okay? If you had a triangle that, sorry, we're just going to ignore that, and it was like this, okay? It doesn't matter, all right? It doesn't matter how it's shaped, okay? It could be a scalene, it could be an isosceles. It really doesn't matter, okay? Whatever you call the base, okay, I could call this the base, all right? And a line that's perpendicular between the bases. Now, this only has one base. So, if I take this perpendicular line, should have made it dotted. I take this perpendicular line to the base, okay? I'm still going to use this whole thing as the base, and this is going to be the height, okay? Some people were thinking, oh, I'm splitting this in two, so I'm going to have to multiply that times 2. Nope. It's still the base times the height. I don't do it times 2 up here because I have 2 bases and 2 heights. I don't do times 2 here. Okay, so I'm not going to do times 2 here. It's just 1 base times 1 height. Okay, so now let's talk about today's lesson. So hope that if there was some confusion, and I can see where there could have been, I hope that kind of helped. Okay? All right, so what we're looking at today, if you look at 9.4, which is the area of a circle. Now, I'll try to explain a little bit about what they're doing here. So let me change the camera just a little bit. So I'm using different colors than the book did. But if you see that the first thing they did was they took a circle and they divided it into 8 equal pieces. And they colored 4 of those pieces, those pizza slices, if you want to say it, they colored 4 of those dark blue and 4 of them light blue. So what I did, instead of changing the color of my pieces, okay, I've got the green pieces here, and if I flip the green piece over, it's white on the other side. So I would have half of this green and half of this white. And what they're showing you is, like they show the dark blue, and they go around here like this to the other dark blue. Now what is that? That's half of the circle. And the distance around the circle is the circumference. So the distance here is 1/2 of the circumference. So that's what they're showing you up there at the top of the page, and they have written 1/2 circumference Now, what does that look like down here? If I take this apart and I put the green pieces going one direction and the white pieces going the opposite direction, notice I've got 4 of each. And when you look at this, it should look a little bit like a parallelogram. Okay? And so if I'm doing a parallelogram from here to here, that would be your base. Okay? But what is that? It's 1/2 the circumference. So that's where this is coming from. 1/2 the circumference. Okay? Hope you're following that. Now, as far as base times the height. Now, if I look at this and think about this, going from right here, where that point is, to the outside edge, okay, perpendicular, that would be your height. Well, where's that coming from on the circle? Look at where that point is. That's the center point of the circle. Out to a point on the circle. Think about that for a minute. What is that? A line segment goes from the center point to a point on the circle. What is that? It's the radius. So, when I'm going from right here, this point, I'm going at a perpendicular line up to the circle, I'm actually doing the radius. So radius is the height. So that's why they're showing you that you have 1/2 the circumference times the radius. 1/2 the circumference times the radius is going to be the area. Just like with the other ones, even though I had 2, I didn't have to take that and multiply it times 2. So when I'm finding this semicircle, there are 2 semicircles, I don't have to find both of them. Just one. One base times one height. 1/2 a circumference times 1 radius. That's what they're trying to show you. Okay? Now, so here's your basic formula. Now I could rewrite that just with numbers. 1/2 circumference times the radius. Okay? So this is what area is. It's 1/2 the circumference times the radius. Okay? So now, let's substitute in for the circumference. Okay? Circumference, the way that we find the circumference, and if you look back a few pages, we were doing the circumference. You have to go back a little bit. But the circumference of a circle is, so I'm still going to have this 1/2 here, right? And C, I'm going to put in parentheses because this is all C. Okay? This is 2 pi r. If you remember, the circumference of a circle is pi d, diameter. And what's diameter? 2 radii. So I can put 2 pi r. 2 pi r is the same as pi times d. So I'm going to substitute that in for the c. C is equal to 2 pi r. So I substituted this in for the c, and then I still have this r out here. Okay? So that's what they're showing you. Now, they're using the associative property to regroup. So they're going to group 1/2 times 2, okay, times pi, all right, 1/2 times 2, and then pi r, and then times r. So pi r and the other r. 1/2 times 2 is 2/2, which is 1. 1 times pi is pi. And r times r, now here's where some of you guys made a mistake the other day. R times r is not 2r. 2r would be r plus r. R times r is, you guys forgot, r squared. Remember, the exponent tells you how many times the base is a factor. R is a factor twice. So there is your formula. That is your formula for finding the area of a circle. Pi r squared. So if you know the radius, you square it, you multiply it. Now, squaring it, don't take r times 2. You do r times r. Radius times radius. If the radius was 2, 2 times 2 is 4. Okay? If the radius was 4, 4 times 4 is 16. Not 4 times 2, 4 times 4. All right? And so, and pi, we always use 3.14. Okay? That's it, guys. That's how you find the area of a circle. All right? So, if you look over to 9.5, this is area of similar figures. So, we're going to say goodbye to this. Again, if you missed it, or it just was too fast for you, you don't know where we got this or that, you can back up the video, you can look at the other teaching videos, you can look at the PowerPoints. So now I want to talk about similar figures. Remember, if they're similar, they're the same shape, but different size. So this goes back to, guys, proportions. Proportions. So if I have, like their example, they have 2 on the side, 5 on the bottom on the smaller rectangle, and they have 6 on the side and 15 on the bottom for the larger rectangle. Okay? So think about this. The area of this rectangle should be in proportion to the area of this rectangle. Just like when you're doing a smaller photo and you were enlarging it, what the ratio was. Okay, they had to have the same proportion. Okay, So that's what they're showing you here. The same thing is true of the areas. Okay? So if we call this figure 1, then area 1 would be 2 times 5, which is 10. So that'd be 10 square units. And this area 2, this other figure, area 2, would be 6 times 15, which would be 90 square units. Okay? So they're showing you that much, and then they're saying that area 1 over area 2, the area of 1 over the area of 2 is going to give you a ratio. Okay? So if I do that, area of 1 was 10, and area of 2 was 90. So if I simplify that, okay, that's an area, or that's a ratio of 1 to 9. Okay? So if you're going to have any other rectangle and you want it to be proportional, it's still going to have this ratio of 1 to 9. So this right here, remember, comparing two ratios, that's called a proportion. So all of your problems here in 9.5 are all going to have to do with this formula for area that makes them proportional. Okay? So whether you're doing area 1 over area 2 or area 2 over area 1, okay? Doesn't matter. All right? And so they further tell you, they give you this formula. So again, we've established area 1 over area 2 is going to be the ratio. And look what that also shows you. The sides have to have the same ratio. So it would be side 1 over side 2. Area 1 over area 2 and is equal to side 1 over side 2. So way we would read this, proportion, the area of 1 is to the area of 2 as side 1 is to side 2. Area 1 is to area 2 as side 1 is to side 2. So that's your basic formula. And on all these problems, if it gives you 3 of them, okay, you can find, if you wanted to find out what the area of figure 1 was, you knew the area of figure 2, and you knew the measure of one of the sides, and the corresponding side on the other figure, this ratio is also going to be this ratio. Okay? Hope that explains it to you. If you think about it, if you need to, you play it back and look at the examples and everything, and it should kind of start making sense to you. All right? Hope that helps. Again, message me either in Classroom, in Dojo, or by email. And I'd be glad to answer questions for you. Okay? So if we have a snow day tomorrow or today, enjoy your snow day, and don't drive your mom and dad nuts, and quit picking on your brothers and sisters, and because if you do, Easter Bunny's not going to come and see you, and that would just be terrible. All right? So take care. hope to see you soon. We miss you guys. God's blessings.